All right.
No. Warm all day yesterday.
Okay. Hey, real quick, let's go through a couple notes here. I want to go through a couple sentences again, and then we'll get to it. All right. Head off. All right. Here we go. First thing. Are we comfortable with if-then statements? We know the hypothesis and conclusion. Now, here's what I'd like you to do. I have one sentence I'd like you to write down here, and we're going to use this basically for our first example. What the homework will eventually bring. No, we're not having homework today. The goal today is to introduce what we're going to be doing the next couple days in here. Okay? All right, so here we go. First sentence I'd like you to have written down. All rhombi are parallelograms. Okay, that's the first sentence. Now, do you agree it's not in if-then form?
Yes.
Okay. The first couple problems you're going to have, I think I give you 2, 3 of these, something like that, on the homework eventually, is to rewrite this sentence in if-then format. Okay, so what you really need to do is identify, like, what's the hypothesis, what are they trying to show, what are they trying to prove the conclusion. Rhombi, by the way, is plural for rhombuses. That's what rhombi. So the idea is that if you want to try to see what the hypothesis conclusion is, the hypothesis is that the figure you have in front of you is a rhombus. That's your hypothesis. The conclusion, this is the conclusion that they're all parallelograms. Now, when you rewrite the sentence with if-then, you can add more words in there. You don't need to use exactly the words that they had. You have to make a sentence that's grammatically and logically that makes sense. Okay, you can't just go, okay, if all rhombi are parallelograms, then they're parallelograms. Like, that doesn't make any sense. You just repeated yourself. It has to make somewhat of logical sense. So here's what I would say. This is what I want. If a quadrilateral, okay, if a quadrilateral is a rhombus, then it is a parallelogram. Now, I know that I added a few extra words, but I made it grammatically and logically so it makes sense, right? I said that, okay, I start with that concept that your figure, whatever it is, I said it's quad, is a rhombus. The logical conclusion I want to make is that it has to be a parallelogram. That's what I'm trying to convey with that sentence. It has an if, it has a then. Does that make sense? You would not believe how many people are going to butcher this because they just read the sentence and then they just try to put if then in the middle of that sentence and it doesn't make any sense. So, if it's a that type of shape, if it was a triangle, I'd say if this figure is a triangle, then because you don't have to use quad. I just know it's a four set of figures. So. All right, now notice I didn't even say if it was true or false. I just went after that sentence. This sentence is actually true, by the way. If you have a rhombus, it is a parallelogram. It's a subcategory to a parallelogram. And a rhombus is the subcategory. It's right next to a rectangle. So they are parallelograms. They are quads. So. All right. Questions with the first part of the homework that you're going to eventually have probably tomorrow? Too many conversations. Okay. Second part of the problems that we're going to have. Does everyone have that written down, by the way? Okay, it's going away. All right. Second part. Now, they're going to talk about related conditionals. This is the part we focused really heavily on yesterday. I spent way too much time on it. Today, I'm going to go through these way faster so we can get to the logic grids today. Not logic grids, the truth table, sorry. Related conditionals is anytime you want to write a sentence in a different format. So like, for instance, if you have a normal sentence and I want to write a converse for it, or I want to write an inverse or a contrapositive, one sentence, then you need to see like how they work and how they all fit together. So the first one we're going to focus on is a converse. We're going to just start with that one. I'm going to show you how to write a converse. I don't care if they're true and false today. I'll talk about it. One example I'm going to use one sentence, And we're gonna do all 4 types to that one sentence. Because yesterday I was kind of bouncing back and forth. Today I'm gonna do it all for one, so you can see how they all fit together. Okay, so Converse. This is the problem. This is the definition I gave you yesterday. Is an exchange between the hypothesis and conclusion of a normal conditional sentence. Okay, so here we go. Here's your conditional statement. This is the original sentence I'm going to give you, and we're going to mess with this sentence over and over and over today. Alright, so conditional statements. Here it is. This is the one we're going to use. So, if an angle's measure is 25 degrees, then its complement is 65 degrees. Okay, I'd like you to write that sentence down. We're going to mess with this sentence over and over and over today. This is actually a true sentence, by the way. It's not important that it's true or false to write the other ones, but I want you to know that it is true to begin with. An angle's measure is 25, its complement 65, because what does the word complement mean? Goes along.
It adds up to a right angle.
Adds up to 90. So 25 and 65 add up to be 90. So this is true. If an angle is 25, its complement has to be 65. They add to make 90. So that is a true statement. In fact, it's a property of math, so that's why this is going to be important to know that. We're going to write this as a converse now. This is what the whole first slide is about. Can we write it as a converse? Converse is taking the hypothesis and conclusion and interchanging these two. Now, I don't know how you want to do it. That's because it's kind of a free-for-all when you want to write a converse. The last class, I had somebody just said, just switch the 25 and 65. Just switch the numbers. You can do that, and that's a converse. Because maybe you thought the hypothesis was the 25 degrees, and the conclusion was the 65, you could switch them. I would probably say it's probably safer to switch the actual words as well, just so it grammatically, like, you're changing the sentence fully. But this is what I'm looking for. I'm looking for the converse on this one. So here's the sentence that I would probably write. Now, it's not wrong if you want to switch 25 and 65, but I would say, if an angle's complement is 65 degrees, then the angle's measure is 25 degrees. So I did switch the words up a little bit. That's a converse. Now, on this one, the converse just happens to be true again. I know that's different than yesterday. Yesterday they were kind of bouncing back and forth. This one's true. If an angle's complement 65, then the angle had to be 25 in the first place. The reason being, it's literally a definition of complement, that the angles have to add to be 90. So, since it's a property in math, it's going to be true in every sentence I write today. Even the inverse and the contrapositive are going to be true. Alright, questions on the first one. Does everyone see how I switched the sentence around? Tomorrow on the homework, you'll have 4 of these, where I give you a sentence, one sentence like that, if then usually. Then you have to rewrite it as a converse, you have to rewrite it as an inverse, you have to rewrite it as a contrapositive. So there should be like 3 sentences for every problem you have. There's, I think, one problem I assigned where it wasn't an if-then form, you have to rewrite it, then you can start the problem. So you'll actually have 4 sentences. Okay, but does everyone feel comfortable with what a converse is? Do you see how I just switched the parts around? But again, I did paraphrase, like I did use different wording when I rewrote it to make sure that it makes sense. Okay, let's go to the next part. So next sentence. Now what we're going to do is we're going to do an inverse now. Inverse is based on the original sentence. So if you look up here, we're going to negate the hypothesis and conclusion of the original. So I'm going to get rid of the complement here. Hopefully no one needs that. Okay, so here's my sentence again. You already have it written down. You already have my original sentence. An angle's measure is 25, then its complement 65. That was my original sentence. Now what we're going to do is we're going to do an inverse. Okay, For the inverse, all this is, if you look up the sentence up here, we're taking the original sentence and we're negating means we're going to throw the word not in there, for the hypothesis and conclusion. So I'm going to rewrite this sentence out, the original sentence is in inverse now, but I'm throwing the word not. So if an angle's measure is not 25 degrees, then its complement is not 65 degrees. Now this just happens to be true again, because I already told you earlier that this is a property of math, so that every sentence we write should be true if it's a major property of mathematics. Well, when you throw away the 25 degrees, that an angle cannot be 25 degrees, there's no way that the complement of the angle that's not 25 is going to be 65. So you have to throw that 65 out as well. Because it's any number but 25, so that it has to be, every complement has to be other than 65. Okay, does everyone understand how the inverse works?
Yes.
Okay, you're going to have to do that for a sentence. Because remember, tomorrow, I'm giving you 2 or 3, I think, where I give you a sentence, and you have to write the converse, the inverse, the contrapositive, so here's the inverse for that sentence. Okay, we're good? Last sentence today, does anyone still need that? Okay, I'll take it, I can erase it. Okay, last part here. Contrapositive. Okay, contrapositive is where we're going to negate the hypothesis and conclusion of the converse sentence. Hey, too many conversations here. Let's knock them off right now. So, we're going to negate the converse sentence. So, what we have to do first on this sentence, we have to write the converse. We have to write the converse for this sentence. So, the converse is the one we did earlier. That was the first sentence we wrote today. So, I'm going to rewrite that back up here. So, if an angle's complement is 65 degrees, then the angle's measure is 25 degrees. Okay, that's not my final answer, right? That was just the converse, that was the first slide that we went through. You switched the 25, 65 around, I made it so it made sense grammatically. What we need to do on this one is the contrapositive. We have to negate that converse sentence. The converse sentence. So we're going to negate this one. So, contrapositive throwing the word not into this sentence right now, this new converse sentence. So, if an angle's complement is not 65. Gentlemen, shut up. So, then, the angle's measure is not 25. So, angle's complement is not 65, and the angle's measure is not 25. It's the same sentence as the converse, but the word not is thrown in. This is still true because that simple fact that this is a property, so everything works out. Every inverse, contrapositive, converse is all true.
So, on the homework, you'll ask for all 3 of those?
I'm going to ask for all 3. There's 1 or 2 problems in particular that they're not going to give you an if-then statement, so you have to write that sentence first. You have to write all 4 sentences. I don't think they ask for true and false on any of them. They just ask you to write all 4 sentences. Now, when you write these down in your homework tomorrow, you do have to label which sentence is which. If you don't label that, I count them wrong. So, you have to label this one's the conditional, this one's the converse, this one's the inverse, this one's the contrapositive. Once you have them labeled, I'm going to read them. And they have to make sense. You can't just switch words and make it all jumbled mess. So make sure that if someone to read it, they understand what that sentence is actually saying. Okay, we good?
Yep.
Alright, somebody's phone keeps blinking, so maybe I'm going to turn that flash off and get notifications. Perfect, thank you. I want you to read the sentences for P, Q, and R. I want us to be able to set up a truth table without it. Now, what's weird about that, what I'm trying to find, what the truth table at the bottom, what's weird about that bottom sentence? I want to see a new symbol.
It has to be both of them.
Has to be both, because the word and, but what's
Squiggly.
the little squiggle thing? Yeah, that's a weird symbol. So, I'm in agreement. Now, it has to, if you didn't hear him, it has to be both. This is the word and. It's a compound sentence. It has the word and. That's a little, like, up arrow key. We talked about that yesterday and Friday last week, or actually Thursday last week, we introduced those. And means it has to be both. So both of them have to be true for this to be a true sentence. So this is not going to happen very often. This is probably a very small percent. Now, what the little squiggle means. This symbol, little squiggle, means that we're going to negate P. So that means we're going to do the opposite of P, or not P. Okay? And this one is just the regular R itself. So that's just traditional R. So negation means we're going to throw the word not in there. Okay? I'm not even going to write the sentences up there to begin with. I don't care about what the sentences are. We're going to fill those in here in a minute. For right now, I want you to get a sense for how to do a truth table when you don't even know what the sentences are in the first place. So I thought that was important. Okay, put your name on the back wall. Is there a marker back there? Perfect. Okay. Okay, so let's go through this and let's set up our truth table. So, truth table here. We're going to have, in this problem, we're going to have 4 columns now. That is different than yesterday. Now, why this one has 4? Even though I don't even know how many sentences are in the first place. Okay, there's 4 columns. The reason why. Number 1, you have to have a P column. You have to have an R column. You have to have those. And those are like the gimmies, right? The third column is we have to negate the P, because this one had a little squiggle on it. So we have to have a column that has the negation of P. That means we're going to throw in the word not in there and have all the opposite meanings. And then the last column is the one we're looking for. We're going to go the negation of P and R column. That's the answer we're looking for in the very, very end. So this one has 4 columns. It's still going to have, all the different setups to it, but that's the set. Okay? Okay, is everyone good? Everyone's got their truth table set. Okay, we're in the P and R in the beginning. We're going to make every combination of true and falses for those sentences. So I don't even know what the sentences are. I don't even have them printed up there yet. But I'm going to look at, is P true? Is R true? That type of thing, and make every possible combination. I'm ignoring the back 2 columns. I don't even care about it. So what are the different combinations of trues and falses I could have?
True.
Yeah, both sentences could be true.
True, false.
True, false sentence could be false.
False, true.
False, true, the first one could be false.
False, false.
Yeah, both sentences could be false. Because we don't even know what the sentences are. I didn't even print them for you yet. Whatever the sentences are, I can fill those sentences later. So these are all the combinations of true and falses that could happen here for 2 problems. Okay, it's not 3 sentences, it's 2 sentences. Okay, now we have the negates. So now this is the column with the not P column. The easiest way I can tell you how to do this one, for the negation of P. All you're going to do is you're going to look at this column right here, the one with the normal P, and pick all the opposites. So, if it went true, true, false, false, what's the opposite of that?
Also, true, true.
Yeah, false, false, true, true. It's the easiest thing in the world once you understand how a negation works. You're making the opposite meanings going down. And then now the last column is where, if you didn't hear Hassler earlier, he was saying that they both have to be, they both have to work. We're including both, because this last column now is what we're using to find this answer. It's an and, by the way, so that's why they have to be both. So this is an and. They both have to work. We're using these 2. I'm not even using the first column. The first column's done. I only needed the first column just because I needed to negate it later. Okay, so for this and to be true, both sentences have to be true because that's what the word and means. So are these both true right here?
No.
No, so that's a false sentence. Are these both true?
No.
No, that's false. Are these both true?
Yes.
Yes, so that's a true statement. Are these both true?
No.
No, so that's false. For an and problem to work, both have to be true. It's like if they said at lunch you're having nachos and spaghetti, and they don't give you one of them, that's a false sentence. They have to serve you both. I have no idea what you have for lunch right now. Okay, now, the probability of this being a true sentence in the very end, without even knowing the sentences, the probability, the likelihood of this event occurring is, for this to be a true sentence, it's 1 out of 4 chances. 1 truth out of 4. 4 options. It's 1 truth. That's 25% chance of this being true without even knowing what the sentence is to begin with. There's 3 chances out of 4 for it to be false. That's 75%. Because there's 3 F's in that truth table. So this is not good likelihood that we're going to get a true statement here, even though I don't even know what my sentences are. Does that make sense what a truth table is? Now, I thought this is important today that we looked at truth tables without sentences. Because some people just go, well, I don't need to do that. I can just go look at the sentence and then tell me if it's true or false right away, and I don't need to write the whole table. The whole point of doing a truth table is to know your percentages. Is it true or false? That type of thing. The percentages change depending on how many sentences you have to deal with. There could be a lot. Alright, we go with kind of the easier one. I consider that an easier truth table. I know that you're probably thinking, oh my god, that was kind of tough. You haven't seen hard yet. Okay, are we good so far? Alright, let's do a difficult one here. Let's do one where we have to actually put a little bit of thought and effort into it. Without knowing sentences yet. I thought this was important that we don't know sentences. Next one. 3 sentences now. Not easy. This sentence is going to have a lot of columns. A lot of columns. Because we have 3 sentences, P, Q, and R in this thing. We're doing an OR. So just knowing that this is the sentence for OR, because that's the little V in the middle. This is an OR sentence. This tells me probably the likelihood of this is going to be probably more or less true. Just saying. That usually these are more true than false. This is an OR. But there's still, in this part here, there's an and in here. So that's not good. So there's a lot of stuff we have to do here. I'm going to try to make the column so it makes sense to you, and then we can go from there. Yeah, this is not easy. This is probably the most challenging one you're going to see. Okay, so does everyone understand what we're doing? We're figuring out the overall problem is an OR problem. It's whatever this sentence is, or that one. That's what we're doing. But in the middle, like this first part, we're doing an and problem. So it's 2 sentences with the and. So we've already kind of done those like yesterday. So we're going to go through this. Now, the columns that we have here. We have a lot of columns. Okay, one of the columns has to be the P column. Okay. One of the columns has to be Q. One of the columns has to be R. You have to have the 3 sentences because we have P, Q, and R as our main letters. Now, were any of them negated?
Yes.
Yes, the R was negated, correct? So they have a little squiggly in front of R. So we have to have a column for the negation of R column. So squiggly R. So there has to be a negation of R column. Now, the other 2 columns we're going to have. One of the columns has to be the P and Q column, because that's one of the parts I need to find. I need to find this column. So the P and Q, that has to be one of the columns. And then the last column is going to be the one we're trying to find. The P and Q column, or the negation of R column. So that last column is made, this column, the truth and falses that are made in this column are made from this column here and this one. That's why it's important to figure out all of the options here. Now, the hard part is getting all the truth and falses in the right spots. But we need to get to those last columns to figure out the percentages, what we could have here. And this is not going to be 75 to 25 anymore, because we have way more options. So now we have to make every true and false known to man for those first three sentences. So you have to make every combination. There's quite a few, by the way. All right, so they could all be true. So true, true, and true. It could be true, true, false. It could be true, false, true. It could be false, true, true. So that's basically the options if I want to have two truths and one false. It could be, am I going too fast? Okay, hopefully I'm not. Now I'm going to try to introduce when there's two falses here. So instead of just one false, let's go with maybe it's true, false, false. Or false, true, false, or false, false, true. So that's introducing two falses. And then the absolute last column is where they're all falses, correct? That should be the last option, where they're all three false. I think that's every possible combination of true and false I could possibly have without repeating. And how I always think of that is always like, I think of, okay, they all have to be true, and then I have to have two truths, and eventually, once I get through those options, there has to be two falses, and once I have that, then they should all be false. That's like every combination I should have. Without repeats. Did I miss any of them? I don't think I did. I think I covered my bases. Yeah, I think we're covered. Okay, let's get to the negation of R column. Anyone happen to know what the negation of R is going to be?
That opposite of R.
Yeah, the opposite of that last column I just did. Is the opposite of this column. So it's going to be false, true, jeez, let me get off my letters. False, true, false, false, true, true, false, true. It is always the negation of the column that was right in front of it. That's the negation of our column. Okay? The fifth column now? The fifth column is looking at doing P and Q. This is an and here. So for this column to be true, P and Q both have to be true. So I'm only using P and Q for this next column. I'm going to ignore the R and the R, the negation of R column. So I'm doing P and Q. So are P and Q both true?
Yes.
Yes, that's true. Are P and Q both true? Yes. Are P and Q both true? No. Are P and Q both true? No. P and Q both true? No. Are they both true? No. Are they both true? Definitely no. And definitely no. So there's your options. The and is tough. There's a lot of falses there. Because for an and prime to work, they both had to be true. And that was only the top two rows. Now the last column is finally, we're getting down to the final answer here. This is my last problem of the day, by the way. Is doing this column and this column, and it's an or. So if one of them is true, you're golden. If one of them's false, you're still fine because one of them's false, but if they're both false, that's when we have the trouble, because we're doing an or. This is an or problem overall. So one of them has to be true, one or the other. So, here we go. Are one of them true?
Yes.
Yeah.
Yes. Are one of them true?
Yes.
Yes. Are one of them true? No. One of them true? No. One of them true? Yes. One of them true? Yes. One of them true? No. One of them true? Yes. Okay, there's my options. And so now we're going to count up how many truths were there. So how many truths? 1, 2, 3, 4, 5. There's 5 truths out of a total of 1, 2, 3, 4, 5, 6, 7, 8. 5 out of 8, which is true. Does anyone have a calculator on them? What is 5 divided by 8? It's just over 5. What?
625.
65%?
625.
625? Wait, what? 625? 62.5%? Yikes, that's a lot. That's gonna be true. That means 3 out of 8 are gonna be false. And that's whatever's left. So, 37.5 or something like that? Well, I'll have to double check my math there. Okay, that is false. And again, double check my math on that, 38.5. I was tracking my head, I'm not very good at that. Okay. Are we good with truth tables? If you could follow that at all, you're more than fine. You're not getting homework today. The goal of today was to talk about truth tables for the most part. Tomorrow, for sure, you need to have a textbook. Be ready to go. But is anyone going tomorrow for the SPSATs? Okay, good. I think it was just select few juniors, I think we're selected for that. Alright, well that's it for today. That's pretty good.